Let's dive into the world of functions, starting with linear functions. These are your go-to for converting quantities, characterized by the equation y equals mxb. The constants m and b dictate the slope and intercept, shaping the graph into a straight line. Visualizing linear functions is straightforward. Find 2 points, use them to calculate the slope, and you've got your function's rate of change. It's a simple yet powerful tool in mathematics. Now, consider the points 0, 15, and 30 on a line. Calculating the slope, we find it's minus 5. With b equal to 15, our equation becomes y equals 5x 15, a perfect illustration of how linear functions graph. Moving on to quadratic functions, these form parabolas on the graph and are expressed as y equals x2b xc. Depending on the sign of the parabola opens upwards or downwards, essential for modeling projectiles. The vertex of a parabola, where it turns around, is crucial. Whether it opens upward or downward depends on a, but its exact location is influenced by all constants a, b, and c. Power functions introduce an interesting dynamic with the form y equals x. The exponent b determines the symmetry of the graph, making the function behave differently for even and odd values of b. When b is a negative integer, power functions show diminishing values as x increases, a useful property in certain mathematical models, particularly in physics and engineering. What if b is a fraction? These functions start at 0 and their graphs initially shoot up vertically before curving back down, providing a unique visual in graph behavior. Polynomial functions bring more complexity involving higher degrees of x. They can model a wide range of phenomena, from natural growth processes to general data fitting. Each polynomial function has a unique shape depending on its degree and the sign and magnitude of its coefficients, offering a rich toolkit for solving real-world problems. Radical functions, with variables under a root, are intriguing. Their domains are restricted to prevent undefined operations, such as taking the square root of a negative number. To identify the range of a radical function, you experiment with various domain values. This careful consideration ensures the function is well defined across its intended range.